All right, so this is the equations of circles packet, and we are going to look at problem number 1, how to write the center. If we look at the instructions, it says find the center and the radius of each. So, looking at number 1, in our notes we found that the center was going to be a point h comma k that fell into the formula x minus h squared plus y minus k squared equals r squared. So since the h and k both have negatives already, then I am looking for the opposite version of them. Since this one's negative, h is actually positive 1. And since this one is positive, h is actually negative, or k is actually negative 3. So the center of that circle is 1, negative 3. And the radius is going to be equal to, so if this is r squared, and in this case r squared equals 4, I can write it like this: r squared equals 4, square root both sides, r equals 2, because the negative 2 is not going to be used in geometry for length. Okay, so our point is 1, negative 3. That's right here. The radius is going to be over 2, down 2, left 2, up 2, and draw yourself the circle. Bada boom. All right, we're going to skip to number 9 on the back. And this is pretty much the same as the front. It's just in reverse. We're going to give you information, and you need to write the equation. So in this case right here, they're giving you the center and the radius, so that should be pretty easy for you. You're going to plug it into that x minus h quantity squared plus y minus k quantity squared equals r squared. This is just Pythagorean's theorem. The h and the k are right here. So when I plug those in, sorry, this thing is freaking out. When I plug those in, I get x minus 13 quantity squared plus y minus a minus 13 quantity squared equals 4 squared. And that means I'm going to get x minus 13 squared plus y plus 13 squared equals 16. Done. All right, let's take a look at number 10. So if I've got a circle and the center is at the point negative 13, negative 16, and then there's another point that is at the point negative 10, negative 16, then this is the circle we're talking about here. Well, it looks like I can find my radius because it hasn't gone up or down. This is still the same. The y value is still the same. So all that changed was the x distance, and it looks like it moved 3 units. So that's 3 units long. So I know my radius now, r equals 3. And I know my center. Go ahead and write the equation. I'm not going to do it for you, but you know it should be x plus 13, y plus 13, and r equals 3. So that'd be 3 squared on the other side. Number 12, the center is at 10, negative 14. So if the center is at 10, negative 14, and it's tangent to x equals 13. So we need to ask, what is this equation x equals 13 going to look like? Well, whenever I graph x equals 13, it's kind of like, I imagine it like an Etch-a-Sketch. If I lock the x value, and it has to be 13, then it starts here at 13, and it can't change. But the y value can, and if you have an Etch-a-Sketch, then the y value could start drawing up, it could go down, it could go, and it's just going to make this line. Because the x value's changed, it can't move left, it can't move right, it can only go up and down. It's like turning one wheel on the Etch-a-Sketch and not the other. So this is going to be the line x equals 13. And what I know is that it's tangent to the circle. That means it comes and touches that line at one point, and therefore it would be the point that is, I know I didn't draw this right, it should be perpendicular. Right there you go. Pretend like that's perpendicular. And so that's going to be the point 13, negative 14. It's going to be on the circle. So the radius, once again, equals 3. You know the center. Go for it. Okay, here, once again, just another way to find the radius. The area is 25 pi. Try to figure out what radius would give you 25 pi for an area. Now, this one over here is kind of interesting. It does very similar to the last one with the tangents. So let's just draw what we've got here. X equals 8. We said that was going to be the line where X is stuck at an 8, but Y can go up and down. X equals 14 is the line where X is stuck at 14, and Y can go up and down. And then Y equals 3 is the line where Y is stuck on 3, but X can go up and down. So where could I put a circle so that its center is in the first quadrant and it touches all 3 of these lines? It has to touch each and every line one time. Well, it looks like I can put a circle here, or I could put a circle here. And the question is, which one of them do we know for sure the center is in the first quadrant? This one, it looks like the center might be on the line or below the line, but this one, it's definitely in the first quadrant. Okay, we can even measure just to make sure. This is going to be how many across from 8 to 14? That's going to be 6 units. So this is a radius of 3 and 3 here. This is 3 and 3. Okay, this has to be 3. 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 So can I find my center? I already know the radius is equal to 3. And obviously from this one, since this line right here is 3, to go 3 down means I'm going to be on the x-axis. And therefore, it's not in the first quadrant. It's in between the first and fourth quadrants. So this cannot be our scenario. But this one, once again, for sure is. And it's from the line y equals 3, I've got to go up 3 units to there. So that's going to be the line where y is equal to 6 here. So at this point, y is 6. So I could say that my center, the y value has to be 6. The question is, what's the x value? Well, over here, I can find the x value by looking at what is halfway between my 8 and 14. Well, that's going to be 3 units across from 8. So if I start here, it's going to be 3 units over. 8 plus 3 is 11. So that means my x value is going to be 11. My center is 11, 6. My r is 3. Write the equation of that circle. And now I'm going to switch over to another video to do the last one.